Hello and good afternoon, everyone, and welcome to our AI training with AMD. I'm Sima, as Mari introduced me. I'm the work package 3 leader of CASTIEL 2 project, and I'm delighted to open this 4-day program. This specialized training is a fantastic collaboration of 3 key organizers, as you know, AMD team, NCC France as part of EuroCC 2 project, and CASTIEL 2 Work Package 3. And I would like to introduce our experts. I'd like to thank Velasta and also Karim and Marie for helping and for their support. And also I would like to introduce our AMD team experts who will be delivering this session. They bring the decades of expertise in parallel computing and HPC optimization. Dear Bob and Giacomo are here. You can see them. Also, our experts Samuel, George, and Jose. They will be with us for leading these sessions. And I would like to thank these experts for their effort, and thank you all for joining us, and I would like to give the floor to our AMD team. Thank you very much and enjoy the session.
Thanks, Sima. Thanks, Marie.
First, I do want to extend thanks to the whole group for organizing this event. It takes a lot of work and many months. I think we started 7-8 months ago, so it takes quite a bit of time to plan these things to be successful. And thank you all. So we're going to start out with an introduction of our 2 speakers this morning. I'm Bob Robey. I'm the Global Training Lead for AMD, and I've been with AMD for about 3 years. Before that, I was with Los Alamos National Laboratory for 24 years. And my background is in compressible fluid dynamics. I've written a book on parallel and high-performance computing and organized a summer internship at Los Alamos. Let me turn it over to Giacomo for a brief introduction.
Hi, everybody. Happy to be here. Good morning, afternoon, night, wherever you are. I'm in Austin, Texas right now. I'm Giacomo Capodaglio. I'm the other half of the training team along with Bob. My background is in applied math and computational physics. Before AMD, I also was at Los Alamos National Lab for about 4 years. Back to you, Bob.
Okay, we're going to go ahead and start with the first presentation. And just to make it exciting, Giacomo's changed a bunch of the slides, so there'll be a surprise to me as well.
Did it around 2 a.m. Yeah.
Okay, so this is going to be just an introduction to the workshop. Lay a little bit of the ground rules and how to get around during the workshop. First of all, let's create a positive environment. We do want everybody to feel like they can ask questions. And sometimes the simple questions are the most valuable ones, so don't be afraid to ask them. We do prefer that they get asked in the Discord channel, in the QA channel, and the reason is that we have a record of them. So after this event, the chat goes away, and so we're able to respond to those questions for a few days after the event. Let's try to stay positive, and please help others with technical issues. We have a fairly large group here, so it really helps us out if you can steer them in the right direction. So I'm going to give you a little bit of an introduction to the computing systems that we have. So use that dedicated channel for issues logging in or technical issues with the different computing nodes, and we'll try to track that. If we put everything in the main channel, we lose. We can't see the question, the general questions and the general announcements. You can email us directly if need be, and if it's only for you, let's try to keep from filling up the chat channel with questions that are only pertinent to one person. So post there, and then we'll follow up if necessary by email or direct message. The QA channel, as Marie mentioned, this is where the questions go. And we have other people joining this event just to help with the questions. So please post them in this channel, as Marie suggested earlier. We're going to be using SSH keys, and SSH keys always have a fairly large number, 10 to 20% of the people trying to set those up. We're going to have issues and have to follow up with them. Be patient with that. The systems are up for starting last week and will be up for 2 weeks, so you have plenty of time to do the exercises. And we're going to be sharing a small number of nodes, so working after hours in the morning before the session is encouraged. Here's some instructions how to generate an SSH key. And then you send the string in the .pub file. You can do this from a terminal in Windows. There are other utilities in Windows, but they usually hide what's going on. So if you haven't done this before, I just suggest doing it from the terminal. And you will have these accounts, I think, through till the 1st of November, and that we're bringing the system down at that point. Logging in, if your username is different, include that on the login command. If your identity file is not the default, you need the -i identity file. If you have trouble, if you add -v in front of it and send us the log, we can try and help figure out what's going on. Be aware of the permissions on your files that can block you from being able to connect. We do recommend, if you get prompted for a password, to type Control-C, and that's because if you have 3 failures, it'll put you into a banned blacklist, and that's just a security protocol that they have on the system. It takes us a while to clear those blacklist entries. And if you want to set this up in your config file, here are some instructions on how to do that. And as soon as I go to the next slide, you're going to say, but I don't remember what that all was. Well, if you go to the Discord site, which we encourage you all to join, there is a channel called Guides, and we're going to post all the presentations there. And if we have updates, last minute updates, we'll remove the previous ones and post them. And if you set this up in the config file, then it's much easier to log in with just SSH AAC6. And we'll be talking about the Open Web UI a little later today, so stay tuned for that. But if it's working on AAC6, you probably will have less trouble when we go to do that Open Web UI session. You can copy files in and out. Here's some instructions on that. So you can do a secure copy or an rsync. And we do recommend that periodically, maybe at the end of your session, that you copy the files off that you want to keep. So the environment on this system is we use a typical HPC environment. So this is actually a model installation of how we think a site should be set up. And because we're going to have multiple ROCm versions on the system, you have to load one of the ROCms before you see all the modules that are dependent on it. So, there was a previous set of modules with a lot more ROCms on it. We have overridden that with this line to source the override TCL to the LMOD system. So that should already be in your .bash RC file. So for this workshop, we're going to load ROCm 641. And the reason we're going to use that one is not all of the AI packages have been installed yet for ROCm 701. ROCm 701 just came out about 3 weeks ago, so we're still in the process of setting that up. We are running Ubuntu, and you can see the versions of the compilers, which are the default for the system. We're very careful to build everything with the default GCC compiler to try to keep a clean tool chain, and that avoids some issues that are difficult to debug. Here's what you're going to see. This is on the GPU 60 environment, so when you log in there, you're going to see all the modules without having to load ROCm. This is an MI300X, and these modules will show up when you log in because we only have one ROCm version there. It's ROCm 643, so it's a little bit later. So we have both MI300X and MI300A. So even with ROCm, when you install ROCm, we break up the ROCm package into several modules to isolate the environments so that you're not getting collisions. So if you're just doing ROCm, you load that ROCm module. Then you'll see these additional modules. We have AMD Clang, which is the OpenMP compiler. AMD Flang, which is a new compiler, a special release of the Fortran compiler, and it has later versions of all the compilers with it, plus libraries and a lot of the ROCm software. HipFort, if you're interfacing Fortran to the C libraries. OpenCL is supported, though it's not as heavily used as it may have been years ago. And then we got the profilers, which we'll be using fairly heavily on the system. You'll notice that we have 2 versions of AMD Flang. We get a new drop of that about once a month. So ROCm Plus means that it was built on ROCm, so you know that it's dependent on ROCm. And these are all the additional packages. So we have a lot of AI software in here, profiling, community profiling tools, and some IO libraries like HDF5. And a special note about AMD Flang New, we probably won't have as much Fortran in this event, but if you're using the Fortran compiler, it just got released with the ROCm 701 release, but we're still taking a lot of feedback about any kind of Fortran constructs, either in the Fortran language or in the OpenMP offloading that you encounter, so that we can continue to put those fixes into the Fortran compiler. The compiler team is very active right now in trying to or fix all the problems with the Fortran compiler. And it actually is pretty good. We've had a lot of good feedback from it. Your simple commands with the module is module avail, module list, module load, unload. And you'll see them scattered in the exercises over the next few days. But in the compiler modules, we set the compiler flags, CC, CXX, FC, so that when you switch, you get a consistent environment. And you can only have one compiler module at a time. And we also set the MPI compiler flags so that MPI will use that when it builds an application if you're using the MPI compiler wrappers. So on this system, we have two basic sets of nodes. One is this Peri-Peak air-cooled PPAC, which each of those have 4 MI300As on them. And there's a fairly complex naming convention here. The 192 means that there's 192 CPUs on this system, 4 GPUs. The second category is a single MI300A on each node, and it has 48 CPUs on that node. We are using Slurm when you get a GPU, you're getting exclusive use of that GPU. You also need to allocate some CPU because the memory is allocated proportional to the CPUs. salloc, sbatch, sq are some of the common commands. We'll also use srun, which basically does an salloc and runs a command and then exits. And please be considerate with the GPUs. We got a lot of people on the system, and so get on your GPU and then release it when you're done with your exercise. I see one error in here, local queue. We have 2 partitions here, so that's left over from before. Here's a picture of the system. You're going to be logging into a front end login or control node. And then to get to the compute nodes, you're going to need to use salloc, srun, or sbatch. And this gives you a summary of how much memory, CPUs, and GPUs for each node. So there are a total of 25 GPUs for this group. We do have more than twice that number of people getting on the system, so you may encounter some waits at times, and you may want to work on some of the exercises that are more intensive during outside of the hands-on sessions. Okay, so here's a few Slurm commands, give you a sample of what you might want to do. And pay attention to the login message when you log in. I know you tend to just sort of ignore those messages, but we try to put important information there, and we'll be updating it as we need to. We have multiple training events going on in the next few weeks, and so continue to be aware that others may be on the system. So here we can allocate GPUs and CPUs. So --n GPUs. That should just be GPUs, no N in there. And you can also do --CPUs equals 16 or N tasks equals 16. If you want to get a particular GPU node, you can put it in the node list. You can also specify the partition as we're showing with the SH5 partition with the 48 CPUs on each node in the srun command. So I know the SH5 nodes are probably going to be less heavily utilized, so you may do that to get a free node during these exercises. You can set a time. The default is 2 hours. The max is 8 hours. And we may reduce that if we have too much load on the system. Most of the exercises can be done in a fairly short amount of time. Okay, so writing a Slurm batch file, you just take those same commands and put them in the batch in a file, and at the top of it you can put bin bash, and then your actual job you put following the sbatch commands. We have a lot of additional software on the system. If there's a request for anything else that you find missing, we can probably get that on the system. And so let's just go over quickly the AMD GPUs and their architectures. Just to give you a high-level view of the system, we divide things up in what I call the taxonomy of compute architectures. And we have single or multiple memory and compute. And most of us think about basic system, you have compute and memory. That hardly exists anymore. We have a mixture of memory and compute today. But most GPUs are in this discrete GPU category with separate memory for the GPU and the CPU. And you have to move memory back and forth between those two memory spaces. The APU architecture is unique to AMD and for GPUs. And here you have a single memory. The CPU and the GPU are both accessing the same memory. That is where the MI300A falls in this APU architecture. The MI300X is a discrete GPU. And we spend a lot of time talking about memory because this era today really is a memory dominant era where the compute, there's an excess of compute capability, and we have to worry more about memory and memory movement. So conceptually, what's gone on in the last few years is that AMD bought out ATI and combined it onto the CPU chip, but that was really limited to the CPU socket. And so this wasn't really interesting from HPC perspective because there just wasn't enough compute or memory to be interesting. But the breakthrough recently is to put chiplets on the form factor of a GPU where you have a lot more space and a lot more power. And so now this becomes interesting in high performance computing for AI and for these heavy workloads. And we can mix these chiplets. They could be all GPU, or you could have some CPUs mixed in. So that's the hypothetical design. And here's a picture of how this is done with the XCDs and the CCDs, all basically linked via this silicon interposer so that it looks like a single GPU chip. And the HBM memory, high bandwidth memory, is also stacked with vias going through this silicon vias going through the memory so that you get a 2D, 2.5D, or 3D structure to the chips today. And so that's one of the other big breakthroughs in the GPU chips from AMD. And these came out with as products in the MI200. You had two chiplets on the silicon interposer. The 300A, they took one quadrant down at the lower right and put CPUs there. So it's a true APU. And then the MI300X, which is more targeted towards AI and heavy solvers where everything is already on the GPU. And so it's all GPU chiplets. And so that's your basic high-level view of the products we're working with. Here are some numbers. I'm not going to go over them in detail. The 250X and the MI300A, we're seeing a continual improvement in bandwidth, in compute capability, but the MI250X is still has, I believe, 2 systems on the top 10 of the top 500 list for HPC sites. So the 250 is still ranking right up there as one of the top chip capabilities that are deployed. MI300As are just starting to show up there, and we also see some MI300Xs. Now here's a comparison of the 300As and the 300X. And the bandwidth, the theoretical bandwidth is the same, although you get a little more out of the 300X in practice. And the biggest difference for the 300X is you have more memory, 192 gigabytes, and more compute capability for heavy workloads. We're seeing a continual improvement in the floating point capabilities, and we're going to see more reduced precision support in the future architectures. So the programming model, in the past, you had to move memory from the CPU to the GPU and back explicitly. But there was a development in the Linux operating system that allowed you to intercept a page fault. And both NVIDIA and AMD exploit this, grab that page fault, and move the memory for you. So this is called managed memory, or there's many other terms that are used for this, but the memory is being moved for you from one device to the other. So this we call an APU programming model, because on the MI300A, you only have one memory space. You don't need to move the memory. So it's sort of emulating the APU programming or architecture. To do that, you need to export HSA XNAC equal 1. If you see errors that say, can't find this page, it's probably because you forgot to add that HSA XNAC to your environment. There are other ways to set XNAC. We can also do it at the compiler when we compile the code, or at boot time. So there's multiple places this can be done. But for this system, we generally use HSA XNAC equal 1. And disabling it, either unset it or set it equal to 0. So we've moved from this 2 memory space device to a single unified memory. And the big advantage there is I can do one loop on the GPU, and I can do the next loop on the CPU if it's a smaller loop. And this really makes it much easier to port applications to the GPU, or do the lighter loops, the smaller loops on the CPU, and let the GPU handle the heavier ones. Probably the biggest cost on a discrete GPU is moving memory back and forth. So we've really eliminated that cost. There's still a cost for loading the cache for each of them, but you don't have to move the memory. And that's the end of that slide show. So we'll pause for some questions. Okay, everybody has that. It helps to know the architecture when you're running on this and understand what's happening at the lower level, though we don't want to spend too much time really diving into all the details of the architecture. Okay, I think Giacomo, on our schedule, you're up next.
Yes, should I go ahead?
Okay, so we had a question in the chat. What architecture are we running on? The AAC6 is MI300A. GPU 60, which we'll use for the AI knowledge assistant, is an MI300X. So you actually have access to both types. The MI300X is not, we have not set up with all the software, and it does have some trouble with some of the OpenMP that we haven't resolved, but it can be used for some of the AI packages. Okay, Giacomo, I think you're up.
Okay, so let me go ahead and share my screen. Is it coming through okay? All right. Can people see my screen right now?
I see it.
Okay.
Perfect.
Thank you. Okay, yeah, so for the next presentation, we're gonna take a look at what packages are supported from AMD, meaning what packages can run on our GPUs. And let me just give you a heads up. This is not gonna be a tutorial about how to use PyTorch or JAX or CuPy. This is just to show you that you can use those packages on our GPUs. We'll show you how to get them, how to install them, but then it's going to be up to you how you use them. Okay, so diving deep already, here we are showing you what is available for you that supports ROCm in terms of AI and ML packages. And we're gonna go over what we think are the most relevant and most popular at the moment. However, we all know that this might change at any time with AI. And by the way, if you have any packages that you're using that you think are relevant and we should look into, please let us know in the Discord channel, and we'll be happy to engage with you on that. But for what concerns this presentation, we'll focus on PyTorch, which is, I guess, undoubtedly right now the hottest one. And then we'll talk about JAX, TensorFlow, Onyx, CuPy, and MPI for Pi as well. And I don't know if you have looked at our agenda for this event, but there's also going to be a presentation on HIP Python later this week. Okay, so briefly, just to bring up to speed everyone on what we're talking about, there's going to be a quick fast overview of what these packages are very briefly. And we're going to start with PyTorch, which is, as I think all of them, a Python package that mainly provides two high-level features. Tensor computation that is similar to NumPy, that is also provided with strong GPU acceleration, which is what makes it very appealing for the community. And then also deep neural networks that are built on a tape-based autograd system. And there's also several components that come with PyTorch. This list here is taken off of their GitHub repo page. And with PyTorch, you can use those Python packages that you would for sure use in your work, which are NumPy, SciPy, and Cython, for instance. Those are usable within PyTorch. JAX is also gaining popularity, which is a Python library that you can use to do automatic differentiation for Python and NumPy functions. And JAX relies on the XLA compiler. XLA stands for Accelerated Linear Algebra. And we'll see later on that if you want to run it on GPU, then you'll have to also consider something that's called JAX-lib, which is a C++ library that is used to have JAX talk to the GPU. The next one over is TensorFlow, which people tell me is not as hot as it used to be, but then every time we try to count it out, there's someone else that tells me, no, you should still consider it. So, so we're still considering it, and we would be happy to hear from you the amount of usage that you're doing and whether or not you think is still relevant. But yeah, TensorFlow is this end-to-end open source platform that people use for machine learning workflows. And it provides a Python and C++ API. And it also uses this Keras framework here. And you can learn more about all that if you just check one of the many tutorials that they have in their dedicated pages. ONNX stands for Open Neural Network Exchange. And this framework here is used for computation of graph models, and you can take a look at the documentation if you want to find more details about ONNX. Next one over is CuPy, which even though it sounds like an NVIDIA package, is not an NVIDIA package. And in fact, you can very well use CuPy to run on AMD GPUs. And CuPy is one of the packages that's provided in both of the clusters you have access to. And in fact, we have installed it to run on our GPUs. And there's going to be actually tomorrow a presentation only on CuPy. So you'll learn a lot more about that tomorrow. But for now, just briefly, CuPy is basically a drop-in replacement for NumPy and SciPy for you to run on GPUs. And it has something that's relevant to mention right now is also that it provides interfaces for GPU optimized libraries, such as the ones from our side, so RockBlaz, RockSparse, and RockFFT, as well as RICO, which is the collective communication library that's used for AI and ML workloads. As I said, you'll see more about CuPy come tomorrow, but this is just a brief teaser. See on the left here, you see a comparison of the NumPy and CuPy API calls. They're very similar to each other. You basically just have to swap NumPy with CuPy. And on the right, there's a note highlighting that the CuPy specific functions are under the CuPyX namespace. So those are the CuPy specific ones. For those of you that work with climate applications, for instance, as I was doing for some of my time when I was at Los Alamos, you may have heard of Xarray, which is this Python library that works very well if you have to handle multidimensional arrays. But as you may already know, anytime you have big data that you need to handle, then the processing can be unknowingly slow. However, you can use this CuPy Xarray that provides an interface for you to use CuPy in Xarray, so that actually your data processing can become a lot faster. And we have included that in our CuPy installation. So if you want to test it out in the cluster, you also have CuPy Xarray. And we'll talk about that as well tomorrow. Okay, so this table here is somehow meant to give you kind of a 360 view of what is available for you to run machine learning workloads on AMD GPUs. So we kind of have talked about the frameworks. We didn't mention Horovod and Hugging Face now, but those are also options that you have, and deep speed as well. which we have installed along with PyTorch in the cluster. But in terms of libraries, I mentioned some of the heap libraries, such as RockBlast, RockFFT. We talked about Recall. And also there's the option to use Triton as well, Flash Attention, as well as the set of profiling tools that you'll see in great detail in the upcoming days. Olama has support to run on AMD GPUs, and in fact, that's what we're using for the AI assistant right now. And all of that basically relies on ROCm. Yeah, so MPI for Pi, if you're familiar with MPI, is basically just Python bindings so that you can use MPI alongside your Python code. MPI stands for Message Passing Interface and is a set of API calls that you would use basically to do communication, and that, for instance, happens all the time whenever you are, solving scientific problems and you are partitioning your domain and you want your subproblems to communicate to resolve the physics, then you need to pass along information. And we've got MPI for Pi as well in the cluster that's based off of our GPU-aware MPI installation. GPU-aware means that you can provide the GPU buffers to the MPI calls rather than having to make copies from device to host all the time. Okay, so for what concerns portability, because this is day one, so it's the day intended for beginners, but it's very likely there's people that are already working with these frameworks on NVIDIA, for instance, and they may be wondering, well, how does that translate to AMD? What do I need to change? And luckily, in general, the answer is not much, because most of the most popular frameworks are actually there's drop-in support on AMD. So basically, if you have your PyTorch code that runs on NVIDIA, you just take it and run it on AMD GPUs and it'll work. Obviously, to get the best performance, there's going to be extra work that you need to take care of, but in terms of running, that is actually given. For what concerns Triton kernels, you can also benefit from drop-in support, because that's just gonna leverage the ROCm Triton backend. And if you have custom kernels, you're gonna have to heapify them first. So basically replace the relevant CUDA calls with the heap calls. And we talked about libraries. So in terms of how they relate to the corresponding CUDA libraries, well, so we haven't talked about heap a lot, but basically heap is the portability framework that allows you to run on both AMD and NVIDIA GPUs. So these libraries here that we are listing, RockBlast, RockSparse, those are the ones that you would use on AMD hardware. But if you are interested in portability, then you would use HeapFFT, because those are the ones that have the portability layer that will let you run on either GPU vendor. And you would use the ones that start with Brock, because those are already optimized for AMD. So if you know that you're going to be running only on AMD, then that's what you will use. But if you're interested in portability, then you'll use the ones with the heap prefix. And in general, there's always a heap and the rock version, but it doesn't apply to all library packages. So make sure that you are aware of that. And there's also other packages that handle linear algebra that are not from AMD or NVIDIA, but they all support running on AMD and NVIDIA GPUs, such as, for instance, Hyper or PET-C. And those are actually also present in the cluster right now. Okay, so the next question is, well, this all sounds very nice, but how do I get the frameworks? How do I install them? How do I make sure that I can actually run my workloads? So in this presentation, we're gonna go over 3 ways that we believe are what most people are using. And the easiest is probably the container, even though we kindly ask you to not run containers on our clusters because those are just gonna hammer them, and we'd rather not, considering the number of people in attendance. The next one over would be using the wheel, since that is a pre-built package, and that is fast, and it's, I think, what most people are using running AI frameworks. And then there's the trickiest way, which is the build from source. But the build from source makes sense in case you're trying to get the latest of everything, because maybe there's not a wheel available already that takes the latest release into account. So for what concerns AMD, there's the ROCm GitHub that has AMD forks of most of the packages that we have talked about. And the reason for having this fork is that so at AMD, we can make sure that the latest changes to include AMD and ROCm support are integrated, because it's not always the fastest process to have them pushed upstream. So the idea is to have our AMD forks and include those changes there to make them available for users. So I recommend you check them out. However, it's not always the case that the ROCm fork is actually the most up-to-date. And in fact, that's the case for CuPy. And for the build that we have in our system, we have used the upstream repo. And the reason for that is that there's actually a lot of work on our side to get the AMD support pushed directly to the upstream repo. And I'll tell you more about that tomorrow. Okay, so going down to how to use containers to run your favorite framework. It depends on the system you're on, but in general, Docker is, I think, still the most popular. However, because it requires sudo, you may be asked to not use it on certain systems, and you may find yourself using Podman, for instance, or Singularity or Aptainer, which are analogous in the way they work. But here we're taking Docker into account. So you see we're running it with sudo. And the commands you should pay attention to are specifically the -- device equals, because those will make the GPU visible from within the container. And also you'll have to add users to certain relevant groups. We have video here, but you may also need render, for instance, or audio for those users to be able to see the GPU. And then at the very end, you specify what image you wanna run with Docker. So the idea with Docker is that you have some image that somebody else already built for you that has the software you want, and then you just use Docker to run it. So you get on that image that already has the environment that you wanted, and you don't have to install anything. But doing that comes at a cost, because then you have to download the image. The image is gonna be big in size. Maybe you there's something in the image that you don't know but still takes up space. So it's convenient because it takes off of the user the burden of actually installing the software, but then in terms of space and speed is not the best option. So then the next option to kind of have a compromise is the wheel, because the wheel is still pre-built, so you don't have to build it necessarily. You can, but you don't have to. But then the wheel being pre-built, again, you have to kind of make sure that the version that you need and the package that you need is also available. And even before that, you have to make sure that the prerequisites are met, which are, for instance, that the GPU drivers have to be available, and that the ROCm libraries that you need, or even Brickle or MIOpen, need to be already there in the system. And that obviously you have to make sure that the ROCm and the Python version that you have match the ones you are taking from the wheel. So, different operating systems may have different Python versions, so you have to keep that in mind. Taking as an example PyTorch, you can go on their website and kind of like, do a little shopping and select the boxes here that are relevant for you. So for instance, here we're selecting pip, Python, and ROCm, and then you'll be provided with a command, with a pip command that will tell you what to install, basically. So Bob and I come from an HPC background, so we do not necessarily love the blind pip install in terms of just letting pip decide where to install the software, because with Python there's always a problem with a package not liking the version of another package. You always get those messages that pip is neglecting a dependency. And that at times can be a little unsettling. So we always suggest that when you do pip install, you also do the -- target and specify exactly the location of your installation so that you can keep your Python wheel installations self-contained and you don't risk polluting your environment, which nobody likes. Okay, so this here is an example of installing PyTorch with a wheel. So here, see, we have a little message that says, don't use your home folder to install your packages. And here the -t is basically the -- target option that tells pip where you want to install the wheel. And you can actually use a URL to provide a website from where you want to pull your wheel. And once you're done, it tells you basically what it has installed, the version, and so on. And here you see when we run Python to check the import, so to make sure that the package can be imported and it also can see the GPUs, we supply the Python path as well, so that Python can find the package that we have installed. And the problem is always how to manage the Python path. People have their favorite ways, but the way we did it in the cluster is kind of the HPC way. So we have modules for everything. So when you load the PyTorch module, so if you do module load PyTorch, that will set up your Python path for you. So you didn't have to worry about that. And also notice that the PyTorch syntax uses CUDA, which is a little frustrating because you would use that even on AMD. So there's no torch.rocm or .amd. You'll still do torch.cuda to check that the GPU you see it's an AMD GPU. So yeah, so the other option after using pip is to use a virtual environment, which a lot of people like because it's easy to manage your dependencies. I don't necessarily love this approach because, you know, then it means that everybody's going to have their own environment. Whereas if you're in a cluster, I think it's best to just have someone install the packages and then you can load them so you don't have to always reinstall everything in your environment. But you know, this is also an option. It kind of takes out the burden of handling some dependencies, which is good. We like that aspect. And you know, when you create your environment, then you also have to activate it to actually hop on it. And then once you're done, you'll do deactivate and get out. There's one more option, which is using conda, which a lot of people like. I personally don't, but we still provided it in the cluster. So with conda, you have additionally the package manager functionality that you wouldn't get with the virtual environment. So there's actually a module you can load for conda that will give you what you need. And with conda, the thing that frustrates me a little bit is that when you deactivate an environment, there's always something in the environment that kind of lingers. And in fact, we have a module that we have worked pretty hard to make sure that once you unload conda, you get a clean environment. If you find issues with that, let us know and we'll improve it. Yeah, so for what concerns the TensorFlow wheel, with TensorFlow, there's actually a dash ROCm that you need to add to the name if you want to select the specific ROCm supported package. And you can find the available versions at this website. For instance, for this wheel, you have that's built on ROCm 6. Now we are at ROCm 7.0. 2 already, I think. So you can tell that 6 is a little old. Yeah, so you would install the wheel for TensorFlow basically in the same way as you installed it for PyTorch. And then it's always good to check that the GPU is actually visible. So that's very important when you install these packages. You need to make sure that if you want to run it on the GPU, the installation actually sees the GPU, and in this case, in this screenshot, you can see that it's seeing the AMD Instinct MI210 GPUs. For jacks, there are wheels available in the forked repo, so ROCm jacks, and you have to be a little careful because if you want to install jacks to run on the GPU, then you also need other wheels than just jacks, which are the jackslib and the ROCm plugin. But be a little careful because with jacks, we found that as they change and improve the versions, the installation process may also change quite a bit. So we have scripts that we use to take that into account, but just a heads up, if you want to do it on your own with the wheels, make sure that you install all of them. So don't forget the ROCm plugin, for instance. Yeah, so here I'm showing you that we are installing these 3 wheels. So the jackslib wheel to have jacks communicate with the GPU, the ROCm plugin, and then just the jacks Python package. So for what concerns the build from source, as I said, this is the trickiest, but we have this repo here that contains a lot of installation scripts, and in fact it contains also the scripts that we have used to install the software that you'll be using this week. And we have all the scripts here that we have used to install the AI software in the container right now. So we try to make it easy so that you don't have to suffer with the installation from source. And with PyTorch, for instance, we're installing a lot of other stuff that gravitates around PyTorch, such as ROCm Triton, Deep Speed, Sage Attention, Flash Attention, Torch Vision, Torch Audio. So in the cluster, as you load PyTorch, you'll have all of that ready for you with ROCm enabled support. This is just a little snippet of how the build from source for TensorFlow looks like. Notice that the ROCm fork is actually called TensorFlow-upstream, which some people might find a little confusing. And then the tags have these names here that are not necessarily associated with the ROCm version. So the one you currently have installed is version merge-250318. And then there's always a bunch of dependencies that need to be installed. And most of them might require sudo. So, we provide the scripts so that users can technically use them to install in their home directory as well. But those come with the assumption that the sysadmin has already installed the dependencies that need sudo. Because if you try to run it without sudo, if those dependencies are not there, then the build is going to fail. So TensorFlow relies on Bazel as build system. So as part of the installation, we also install Bazel. And then, notice that we are supplying all these environment variables to the installation configure that make ROCm visible. Basically, we tell it that the installation needs to be done with ROCm. So we also have instructions on how to install Horovod. We haven't installed it in the container because not a lot of people use it, but here this is just showing you some of the many actually environment variables that you'll need to set before you do the pip install for Horovod. And this is for deep speed. We have installed deep speed in AAC6. So once you load PyTorch, you'll also load deep speed. And this is the end of the presentation. So remember, this is day one, which is the beginner day. So we're trying to keep it light in a way. But you can already go ahead and play with some of the examples. So if you go into our training examples repo, which is HPC training examples, you'll find a directory that's called ML examples. And in there, there's these two readmes here, readme_AAC6 and readme_ on instinct node that have some kind of like easy examples that in a way mimic what I've shown you in these slides that are a good warm-up for what will come next during the week. So this is it for this presentation. Thanks for your attention, and I'm gonna give it back to the next presenter.
Okay, thank you, Giacomo. Already we've covered a lot of different ways to launch AI packages on the system. But I do want to point out right now that I'm going to pull up the Discord.
Yeah, by the way, I've seen some activity on the chat. We tend to not pay attention to that because as soon as the meeting ends, that's gone. So make sure that anything important is mentioned on Discord. Anything that also needs our attention and our responses.
Yeah, so first post all those in the AI on AMD questions and answers QA so that we have a record of it and we can follow up on it. Also, if you go to guides, we are posting all the slides, schedule, and the workshop exercises in that channel so that they don't disappear in the general channel. We may post in the general as well, but we'll have this for a permanent record. And if you go down here to CASTIEL AI exercises and click on that, you will get a PDF of all the exercises. So right now we're on overview of ML AI on AMD GPUs. Let me load that up a little bit. And it also has instructions on how to log in and troubleshooting hints. So these two on ML AI and AI ML are exercises to go with this previous presentation. The next presentation will be the PyTorch examples here. And so we'll have Jose do that presentation. And then after that, we have a fairly long exercise break to try these three exercises. So let's see if Jose is ready to do his presentation.
Yes, I think, can you see my screen?
We can see it.
Yes. Okay, so for this for this presentation, we'll go through some AI workflow example. I can tell you that Giacomo, who just talked, he has shared many of these already. In this example, what we'll be talking about is mainly PyTorch because it is one of the deep learning framework that is used today. And for multiple reasons, whether you consider AI application profiling or if you consider data parallelism, or even for performance tuning, you will see PyTorch everywhere. And because of that, it is important to know how to install it, how to start with it, whether you are on your laptop, a workstation, or an HPC environment. So here we talk about a virtual environment, Aptainer, Podman, and talk about some module installation. The example we'll be using here is a example, which use machine learning to recognize handwriting digit from a large database. And the PyTorch example set contains a example that use convolution network. So you have this in our training sample. It is available there. Also, what we do here is that for a single GPU run, we'll add just a line to confirm that the code is running on a GPU. So the Python code, you can get it directly from this GitHub. You can add some line to print out the device that is found, and then edit a version of batch, things like that. So what I'm talking about here, if you have the instruction in the exercises, our exercises document. The machine that we'll be using has already been presented by Bob. When you log in, you have access to, you will log in on AEC6, this machine first, and then for computing, you have to do slog to go on these compute nodes, which are all MI300A. Some have 512 gigabytes of memory, while others have 128 gigabytes of memories. So, as workflow, Giacomo talked about a virtual environment. Yes, that is one of the main workflow that is used today. And a virtual environment is basically will isolate your run from the rest of the system. And at the same time, it will create a wholly contained environment, making it more robust. And it is easy to clean. You can clean it quickly after running your workloads. And here we'll show a few versions of running a virtual environment, running a workstation using iterative slum allocation, or submitting a batch version of this. So let's consider a workstation where you want to run a virtual environment using the example, MNIST example. So when you have access to that example, you can create a virtual environment by just using Python -m the virtual environment and the name that you want to use, and then you activate that. You need to activate in order to continue working. After activation, you can install the Rocket version of PyTorch, especially the Torch, and you have different packages. But here we are more interested in Torch and Torch Vision. So this can be done via, you can use pipe install to get these packages. Verify that Torch is working on the GPU, your target GPUs. So to do that, we just do Python-C import, just this kind of command line, and you run it. Here, of course, we use time just to collect the execution time. And after that, you need to deactivate and then clean up if necessary. It is not always obvious to clean up in a situation like this when you have large data sets, and that is the case for most of AI applications. So when we want to clean up, we need to think about, okay, if we still think that we want to use this data or not. In interactive Slum environment, the process is basically the same thing. But here you just have to do an allocation salloc, number of tasks, and number of GPU that you request, or you can do srun directly with that, and the step that we described a few seconds ago is the same after that. Of course, we have some different command line that exist for you to manage, to check the queue, to check the stat and things like that from the Slum or outputs. The virtual environment is Slum bad job. In a context like this, when you have a Slum bad job to run, it is simple. So we need to, as we do for HPC application, we just need to S-batch of the number of GPU we want, the duration of our run, the number of tasks, output and error. We have to provide path to that. And then we create our virtual environment again and follow the same step. Okay, activate, install a Torch and PyTorch. And we follow exactly the same process as we did previously. And if there is any requirement that is missing, you can install that. We have a requirement.txt that exists where you have all required dependencies. You can install and run. The same example after that you deactivate and you can remove. If that is your goal, you can remove the PyTorch, that environment that you just created. Next, in this environment, in fact, you can, in a virtual environment context, as we show, we have the possibility to do in a workstation. We have a possibility to do in a Slum environment as well. And if we go a little bit further, we have a PBS where you can specify something that if needed. But in our case, I don't think that you will need it right now, but it is something we need to mention as well, because depending on the system that you are in, it might be important, useful for you. So importing the Torch, if you look at here, we talk about pipe installer, Torch and Torch Vision, thing like that. So importing the Torch take a live fraction of time. It can take up to 7 minutes, but the training is just for 2 minutes. So after installing, I think it is better if you keep the environment instead of deleting this. And in a context of virtual environment, again, when you have a large training to run, for example, we need to be careful, as we said a few minutes ago, because of the time it takes to install the whole environment. If you have to delete it just after that, I think it is we need to think twice if it is the best thing we want to do or not. Now, after virtual environment, there is another one that Giacomo also talked about. Instead of setting a virtual environment, you can also use a conda environment. And in addition to this, we have also obtainers that you can use as well. And for this one, you can download the image of the obtainer before download the image for the obtainer run prior to the job, so you can get that all these nodes are available. You can pull the .cif file directly, and for this we use the sh5 nodes as Bob described in his presentation to avoid typing GPUs. Module core, you can use CPUs that are available to speed up the downloading and conversion process, but you will still be limited by the network bandwidth. So that is one of the issues that you'll be facing most of the time when you have a large AI application to deal with as well. So pulling the zip file does not benefit from having more core, so it only helps when converting Docker files. And file system sync can also limit the performance as well. And afterwards, you can still clean up, but as we said, depending on the case, you might need to clean up or not. And then image that you got are cached for future use on any nodes. So this means that if you have to do this multiple times, it take a big space, as Giacomo was explaining in his presentation a few minutes ago. So restoring the CIF from a cache image takes significant time. Reuse the rockem.cif file to avoid the startup time. So it is better to reuse most of these CIF files. So for files, so CIF files are large, so don't download them all over your system and be sure to clean up afterwards. So as an example of interactive slum allocation when using obtainers, okay, you can get access to, you can get allocation with a single GPUs as we used to do salloc, and then start up obtainer shells, and that is done via this command line. After that, you can check that the torch is available and there is a usable GPUs. So the command lines are here to do that kind of exercise. And then you prepare to run the example. Our example initially is the MNIST example. So you have access to that. You can install any requirement that is missing before running the pattern called Python main code and time it if necessary. And then you can exit the shell after that. Here we were talking about interactive slum allocation, and the next it is just a slum batch job submission, and it is the same process again. We have our script, and within our script we have the S batch. We have the number of GPU we want. Here we just want one GPU, the number of starts, the duration of our run, and where we redirect output and errors. And after that, we can see that basically the process is basically the same everywhere. We have access to MNIST, the obtainer execution, we have the rockem, we specify the bind, the environment, and the rest is basically the same. And one important thing here is that we specify the zip file. That is really important. And then the process, the rest is the same. And of course, if you want to check what is going on, what output, you can use the command tail.f pytorch mint, and this output refer to the name you gave in the output here. If you look at a system like CNES or Lumi or Frontier, these systems are AMD HPE system. And for this kind of system, you have the AMD Instinct GPUs accelerator that are directly attached to the Slingshot network. So when you are on a system like this, you need to you will need some additional software stack. So here, for example, if you look at here, you will need HPE Cray libfabric implement. That is a part of a Cray software tool. So if you are running on the system like this, for the hackathon we are doing today, we don't have it on our system, local system. But if you want to replicate this on any of system like CNES, Lumi, or Frontier, you might need to the HPE Cray libfabric implementation. To make things work correctly, especially in a context where you are interested in multi-GPU run or multi-node run, especially. So you can run app container in this environment without any problem, but you will need to add some of these libfabric. You will need that. So as you can see here, for example, we are showing some performance of some performance running with and without that plugin. So here we have some message size and we have a burst bandwidth that is achieved. And you can see that with the plugin, we achieve the maximum bandwidth. So this plugin is necessary to run Apteners. So how does it work? So it is important to get an image that is close to the host system that you are using. So it can be SLS 15 for 3OS. So you set up Aptener, you mount this the step. You have all the steps on the right here. So you set Aptener mount path. You can optionally, in addition to this, you can create a Python virtual environment, expand the container if needed. You can execute your code and then consolidate the expanded container into a new image. So what happened basically is that when you get, it is recommended to get utilize a base image that is close to your host system, and then the Docker image converted to Aptenet and made available on the file system. And here you have two options. You can use image directly, or you can leverage Spark to set up the relevant environments. You can then extend the containers as well and add virtual environment if you want. It is optional, but it depends on what you want to do in the system, on your target system. And you might need to consider consolidating the expanded container into a new image. So for the extension, here we are extending container Python installation with a virtual environment. And you can see that, okay, we are doing, we go through the SBatch system. So we are using a Slum SBatch job allocation. So GPU, one GPU number of starts. We specify the Aptener as a command line, we call it. So we have a ROCM, we specify the ROCM, we specify the .c files, and then we create our environment, which is system site pack environment here. After that, we activate, and then we can install any extra package that are missing. To run it, it is the same thing. We start with the same, basically the same command line, but here we are, after activation, we just call Python import transformers, use package from virtual environment directly just to run it. So the header is exactly the same thing. We also call here, we call the proprietary leaf fabric. We talk about, on Cray system, we talk about the leaf fabric. So you might need some software stuff from Cray system, and that is what we are specifying here. So we talk about virtual environment, and after that we talk about Apteners, and another one is a Podman. And Podman, as you heard from Giacomo presentation, Docker containers, sometimes it is has different kinds of constraints, and in a big data center, it is not always what sysadmin want people to use. So an alternative to this is a Podman. So Podman is a Docker alternative that provides a rootless environment. So Docker image can be directly used from Docker hubs. Podman image are stored in the local directory on each node, so it requires separate download and image on each node. And Podman is not installed on the login node as well. So cleaning up use a similar command line like for Docker as well. So you can use Docker image prone or system prone and things like that. So the risk is the same. It is just that we don't want always to use a root. We don't want to give root access to everyone on an HPC system. Of course, there is another way to do this. You can also use Singularity. People might talk about that. But yes, here we are going through few examples. There are many of these examples that are available and suitable in the HPC environments. So Podman here, that is how you use it in the interactive Slum allocation. So we have SRlog, we put the cell SRlog, and we start up an interactive Podman shell. So Podman run IT, so we have to specify this. And we prepare the environment again. We are using our nmist environment, install any requirement, and then we follow the rest. The rest is just to check, to execute few command line. So we import torch platform, and then print some of these to make sure that, okay, we are seeing the GPU, the number of GPU that is available, that we have requested, and so on and so forth. And then we just run the example, we time it again. We can also use the Podman with Solon batch job, we follow the same project and here the same process of S batch. Here we use Podman run. We specify whatever is necessary to run this to make this happen. You can install any requirement as well, and then follow the same, use the same command line if depending on what is what you want to do. So after that, let's say that you have your own workstation. Okay, you will need maybe some module installation. Or if you don't have a module installation to do on your own workstation, maybe it is an HPC environment, and for that one, you can discuss to have some additional installation of PyTorch, or if it is not available, you can talk to the hot site to make this available. So that is why we are talking about this module here. So for a more typical HPC system, we can use custom-built PyTorch and its friends and place it on the system. That way people can use it, and this can be done with pip install to the installation directory, or you can build it from source for better performance. Of course, when on an AMD GPU to use it, you have to specify the target GFS 90A for MI200 series or GFS 940 for 300 series. And the PyTorch installation of the system includes different kinds of packages. You have Torch Audio, Triton, and transformers. The module prepares the necessary path to Python path for the PyTorch package. So it is important either to clear it or whatever is not necessary, because sometimes you can mess up if you don't pay attention to this. So be careful when you are installing this kind of a system. And of course, interactive Slump here is basically the same process. Once you install the modules, you can do allocation, you can do your module load, rock and PyTorch, and then go to the mnist directory, install whatever is missing, and the rest of the command line is basically the same as we used to do so far. In an interactive Slum with a virtual environment, yes, you can combine both as well, depending on your need. You allocate GPU allocations. Here we specify the number of GPUs. You go to the directory mnist example. You create your virtual environment. You have to activate as well before installing any requirements, and then the rest of the command line is what we are doing before. And remember, after activating, you need to deactivate at the end. And then remove the environment if needed. Otherwise, it may be important to keep it, especially when you have you are dealing with large AI applications. Here also you can submit a Slump job with a virtual environment. Basically, it is the same thing. You have you load your module, you do the allocation via SBatch. You load your module or PyTorch. You create a virtual environment, and then you activate, and the rest follow normally. So to summarize, we have a variety of methods that are available. You can use that to run PyTorch applications. The setup time depends on multiple factors, maybe the network load, the disk space requirements vary for each node, and also there is another thing, the type of disk you are using. We will not go through that kind of discussion right now. We are at software level, but if there are many elements that can impact the setup time. Now, a matching version is easier when building a custom image. That is special for modules, and environment in a pre-built. For example, if you have a pre-built Docker or Will, might be always the right way to go because sometimes it can generate different kind of issues. So pay attention to that, and reproducibility might require some effort with each method. But anyway, when you don't want to mess up with the whole system that you already have in place, you might need some of his AI workflow. You might need to set up some of his AI workflow. So far we were talking about a single GPUs. We can run this on a multiple GPUs as well. And as we talk about, PyTorch is one of the deep learning framework that is mostly used in, especially when you have a large AI application to run, and especially when you are doing, what can I say, you have multiple, what can I say, data distribution. You have to do data distribution. So sometimes, most of the time, you won't be working on a single GPUs. You might need multiple GPUs. So this script, for example, is just a modification of the previous one to run on multiple GPUs. We here, for example, if you look at the SPash here, we are specifying 2 GPUs here. For example, the number of task is also 2. So 1 task per GPUs basically, and the output, the rest of the command line is basically the same thing. You have the PyTorch, you create your environment, Rockham PyTorch 2 GPUs, you activate, and you follow the same process basically to do your test, and then after running, you deactivate the environment. So that is pretty much what we have for as an AI workflow example. There are plenty of them, but it is important to summarize this using a PyTorch because you will mostly need it in AI world today. So thank you. I think we have exercise time now. So Bob.
Thank you, Jose. That was really good.
Thank you, Jose.
Thank you.
So we're in the exercise period till 3 p.m. and then we have a 30-minute break. So we have a lot of exercises to go through from the previous 2 presentations. So we encourage you to go ahead and try those exercises on the system and ask questions. We'll be monitoring the Discord for the questions, and please pay attention. You're posting stuff in the Discord. Make sure the questions are going in the Discord channel for the questions and answers, and go to the guides to get the downloads of the presentations from today.
And please make sure that you do not post your SSH keys on channels where everybody can see them, because those are supposed to be private. If you share those, anyone can access your home. So don't do that.
Okay. We'll also open up now if for next 5 minutes or so, if anybody wants to ask questions verbally, you can unmute and ask questions, and then we'll go silent for exercises. So you don't ask questions, I'll ask questions. So I want you to raise your hand if you are using Apptainer at your site.
I didn't see any hands.
Nobody's using Apptainer. How many of you are using virtual environments?
So 1, 2, 3.
Oh, we got some. Yeah. Okay, if Singularity counts as Apptainer. Okay, so we got quite a few using virtual environments. Is there anybody using UV? I guess that's the newest trend in virtual environments. So UV. Okay, we haven't. Okay, a couple. Okay, and how many of you are using Podman? Okay, not a lot of Podman. Geeks. So I do want to stress that each of these methods fits a different situation. So if you've got a site that is heavily using PyTorch, you may want to do a source install. If you're doing a download on your workstation to try something out, a virtual environment might make sense. So we have a variety of different methods, and they may not all fit in every situation. So go ahead and pull up the exercises guide. There's 2 versions of it. If we go to the guides, I'm going to pull it up. So we go to the guides channel, and there are 2 versions. One with HTML that you can download and view that one, or you can go to the PDF version. So you can follow the instructions, and there's a lot of material in here, so you can follow the instructions on how to access the system, then work through some of the examples, pick the ones that are most interesting to you, and you really remember a whole lot more if you work through some of the examples. That's why we do the hands-on examples. So try the Apptainer, try a virtual environment, and try with the modules on the system. And you may try, if you're interested in some of these other packages, you may try looking at those as well. So if we click on the exercise, it jumps to that page, and it has a step-by-step of doing a PyTorch wheel install, PyTorch module, conda environment. So there tends to be more detail in the exercises. And if we look at the HTML version, it's similar. And we can jump to the PyTorch examples with MNIST that Jose talked about.
Do you want to share your screen, Bob, with the exercises so people can have it in front of them?
Thought I did.
Oh, sorry about that.
Is it not sharing?
I was gonna ask the people
I'm
in
sorry.
attendance.
Yeah.
No worries. So this is supposed to be a beginner day. Do people think this is beginner enough? Is it too advanced, too easy? We want to hear your opinions and feedback. This is the first big AI only event we're doing, so we're in the fine-tuning phase to be consistent with the language here. And we're very happy to hear your feedback, and anything you want to share is very welcome. Somebody mentioned spec for their builds. Bob, do you want to say something about Rockamon spec?
Yeah, so we have a sample repository of installation scripts that we use to set up this system here, and we use both regular bash commands with configure, make, install, or whatever the package requires. And then we often use SPAC to install packages as well. Sometimes we have an option for either way. Geeks is also another option. Easy Build, we haven't added those, but there's usually multiple ways to install things. And we want to give examples of many of these different ways of installing. One of the advantages with Rockham is that each package is separate, so you can install just a single package. And on AAC6, we've installed a special HIP FFT, ROC FFT module, which is the latest off the development branch at AMD. You can also put dependencies on a particular package. So if your application requires ROCBLAS, you can put a dependency just on that, and you don't have to download all of the Rockham software. With NVIDIA, you have to install everything, and it may be simpler, but because they're a binary distribution, you can't depend on any part. We have been working with installing all of Rockham with SPAC, and we're still experimenting with that and looking at binary installations as well.
Oh, I see a polling show up. Fantastic.
Yeah, we'll have to do that.
Whoever did that, thank you.
Organizer team. You're not alone.
Best team ever. Thank you.
Pleasure.
Yeah, and so as you've heard, so basically our team handles these two repos. One is the HPC training examples that has the code examples that we've talked about, but also it has a subdirectory that's called tests that has the test suite that we use to validate the installation that we do. and that we have used extensively on AAC6 and GPU60 to test the installation. And as you can tell, and I actually mentioned it during my presentation, it's very important with these Python packages to make sure that the GPU is visible after you installed it, because it happens quite often that, for instance, with JAX, you installed everything and then there was a problem with JAX lib, and then actually it ends up only just running on the CPU. So if you see that your runs are suspiciously slow, it may be because it's falling back to the CPU, even though you think it's been installed for the GPU. So make sure that the GPU is visible. And there's a bunch of little scripts there in that tests directory that does that. And actually, if in the next presentation that I'll do about the Open Web UI, there's a knowledge that I created that has those scripts as knowledge base. So you can actually just look at that one and see what's there.
And we also have this repository where we store the installation scripts we're using. And so if we go to, we'll look at the PyTorch one because it's ugly.
Ugly in the most beautiful way.
So, oh geez, come on. So it gives you lots of options where to install it and other things like that, module path. But then it installs all these additional packages. PyTorch doesn't like to be lonely. It has lots of friends. So we have Triton, we have Flash Attention, we have Sage Attention, but we also use GPU aware MPI in the build. And we give options to use a wheel to build. But if you're using a wheel, it's going to be generic. It's going to be for any system. And so it cannot be optimized the way you can if you do it for your system. This also only installs, let me see, we only install the GFX codes for the system we're working on, and that reduces the size of the image. So this can be a good way to do it if you're running something a lot. This may be a preferred way to do it, especially if you got 50 users all using the same package. But that's a resource also. Okay. I think the hardest exercise is always the SSH keys, don't you think, Giacomo? Or is that for us?
Yeah. Yeah, it's always fun, but the reason why we ask the SSH keys, it's because it's more secure than a password, because if you have your private key in your system and then you just give us the public, then there's that security. Don't send us your private key, especially not where everybody can see it. But yeah.
Okay, we're going to take a break and let Giacomo get some coffee.
I need it, honestly.
And then we'll have the talk about the Open Web UI. Go
Okay.
ahead, Seema. You survived this long. That's great.
Oh, that's a huge coffee.
You get it closer to the camera, it's even larger.
Yeah. Thank you for sharing. Okay, so it's a 30-minute break, right?
Yeah.
Okay. If you need anything, we're still here. But please enjoy this break and see you in 30 minutes.
I see lots of activity on the system, so please work the exercises. Okay, we're approaching the next presentation. We could get Giacomo's slides up.
Yes.
So we are having a bit of difficulty trying to figure out who is still having trouble getting SSH access to the system. Be sure and post in the AI on AMD cloud resources so that we have one place to look and also give us more information than just saying I can't log on. It is difficult with this number of people to know what other information to check for access.
Yeah, and most likely your Discord username doesn't match your username on the system. So if you don't tell us who you are, we don't know that.
Okay, so this next session, we're going to be logging into GPU 60. It should be the same SSH key. If you've got it
Yes.
working on AAC 6, you're halfway there.
Okay, so let me share my screen.
And Giacomo has a step-by-step how to make sure you have access to the system and then to the web interface.
Okay, so I'm guessing the slides are coming through. Okay, so this presentation here, it's gonna be rather short and informal. It's more a demo / tutorial than an actual presentation, but this is basically going to walk you through how to use this AMD AI assistant that we're piloting for the first time with this event here. And the idea is to have it available for you as an additional resource that you can query to answer some of your questions. And hopefully the idea is that it will be able to give you the latest information on AMD software that you would not be able to get in general by using the most popular models that are out there, such as just ChatGPT, for instance. And in this presentation, we're just gonna discuss how to use it, assuming that is already there. Somebody already put it up for you. There's gonna be another presentation, I think tomorrow, on actually how to create it so that you can do the same, and we'll go over the details on what is well, not necessarily the details, but we'll give more details compared to today on what type of model we're using, what is RAG, which is what we're leveraging here for this assistant, and how you can play with the parameters a little bit to try and fine tune what you need. Okay, so first of all, a warning. You'll be interacting with a large language model. So by now, I think it's fair to assume that everyone has interacted at least once with an LLM in their life. So hopefully you already know what are the pros and cons, but just in case it's necessary to do it again, there's a list here of what we think are the pros and cons. And in terms of pros, we think that it's a lot easier than just using Google, because sometimes with Google, to have something show up, Google or any other search engine, you have to kind of have what you're looking for match what's already out there in terms of content, and sometimes you don't phrase it properly, or you exclude something, it doesn't show up, or maybe what you're typing is too verbose, and then you can't find what you need. And with LLMs, that's actually a lot easier, because you can basically ask for something as you would ask to a person, and that's fetching that information for you. And it's a cool thing to use, because then you can also proceed as if you are having a conversation with someone to refine your queries and make sure that what you are requesting is eventually delivered to you. And specifically with the LLM that you will be interacting with, the AMD AI assistant that on the web UI is called AMD AI Training Assistant, since it's based on RAG, that we'll talk about tomorrow, it's also going to tell you the sources. So we have provided a knowledge base with PDFs, PowerPoint slides, code samples, README files as the knowledge base. And so basically a base model is augmented with this knowledge. And therefore, it's also going to tell you what the sources are in terms of what type of information and what specific information has been used to give you an answer. And, you know, other LLMs do that too if you ask, but this one will specifically list the sources at the end, and you can even click on them and see them, and it'll point you to what specific line of that source it used to answer. So that's really cool thing. But now to the cons. As any LLM, it may and most likely will give you incorrect information at times. Keep in mind that LLMs are not deterministic objects, so the same prompt, same exact prompt can give you different answers if you submit it at different times. So you have to be aware that, you know, things like these can happen. And sometimes it's good to just ask again in multiple windows just to see what variability you get, and we'll see that, you know, you can affect the variability of your model with certain parameters, but in general you have to expect that the same question will give you different answers. This specific model that you're gonna interact with is not perfect. It's not fine-tuned to be perfect. So some answers, you know, will be better than others. Just be aware of this, and be aware that if you ask something, someone else in the event may have a different answer than yours. Last but not least, don't take the answers that you get as gold, because yes, we have increased the base model with some very recent, very up-to-date information, but you know, we cannot fully control how that's interpreted by the model at this time with this model that you're given. So it's still possible that some answers will be a lot better than the base model, but some others might be just as good or just slightly better. So, you know, you've been warned. Have fun, but responsible fun. Okay. So yeah, and something else that comes up quite often when we talk about LLMs is this prompt engineering term, which basically just refers to being deliberate and conscious when you provide these prompts to your LLMs, when you interact with them. And there's a bit of debate on what's the best way to actually do that, but in general, I think it's somewhat recognized that there are better ways to do that than others. And in particular, it's very good to be specific and detailed. Obviously, you know, if you are too specific and too detailed, then maybe the context length of your model is not large enough, so that it may just go overboard. So that there's a few caveats that you need to be aware of, but in general, it's good to provide details if you want to have an answer that is on point. You could also give some background information to kind of like set the stage for the answers that you're gonna get. You could establish a persona to begin with. Like here, we're saying, you know, you're an C++ expert, or you could say you're, you know, Python expert, PyTorch expert, to somehow warm up figuratively the model in terms of what answers it's gonna give you. And if you have complex tasks, we've seen that it's a good way to provide a step-by-step recipe of what you're trying to get, so that you can guide the model through what you are trying to achieve. So yeah, so the key elements of a prompt are several, and we have discussed some of them, such as the persona, the context, and the instructions. But you could also, for instance, provide code examples if you're trying to write code to direct the model to what you are interested in. You could set a tone or even supply data, and I'll show you an example later on. You have to be clear about the purpose that you're trying to achieve and also the goal. So this table here is just a visual example of what I was basically trying to convey right now regarding what's good and and what's not so good. So for instance, if we talk about clarity, you should be explicit and avoid being generic in terms of what you're requesting to the LLM. Or, we've talked about structure. It's good to be explicit in terms of step-by-step instructions, as opposed to kind of like ranting, about what you might need and going overboard yourself. And then, yes, you may also have some constraints in terms of, size of what you're trying to expect, in terms of word limits if you're trying to get text, or maybe code if you want to restrict to a certain number of lines. Yeah, and this slide over here gives you more details about some examples on the way your prompt can be structured, for instance, with this chain of thought, or self-consistency, or something that some people call REACT, that stands for reasoning plus acting. You can look through this if you're interested in more details about this. But let's move on to our specific details and how we get down to getting this to work. So you have received your instructions on how to get on GPU 60, which is our MI300X node. And over there, you've been told by Bob, so you don't need to do any salloc, so as you can run on the login node. All the modules are already visible. The software is based off of ROCm 643. PyTorch there is version 2.8.0. You have 2.7.1 on AAC6. However, as tempting as this may sound, we please ask you to not run heavy jobs on GPU 60 because that's the node that we are running Ollama on to power this AMD AI assistant, as well as the other models that you have available on the Open Web UI. So to get on the web UI, you first have to establish an SSH tunnel between your local machine with local port 3000, the remote service port where Ollama is running, that's 3001, and the intermediate server, that's GPU 60. So in the instructions, I sent you this line here, the first one in orange to log in. Well, not sorry, to log in, to establish the SSH tunnel. That works for me and for others in my team, but we've seen that other people need to specify the username before the address of GPU 60. So if the first one doesn't work for you, then the second one will, if you specify your username. Once you've done that, you've established the SSH tunnel, you can copy paste this address here on your browser window, localhost colon 3000, and then magically the Open Web UI login page will show up. And just a heads up, if you close the terminal window from which you are running the tunnel, then the localhost window will not work anymore. Okay, so once you are on localhost in your browser, you'll be in front of a window that looks like this, sign into Open Web UI, and you'll use the email address that you provided to us when you registered for this event, and the password that we sent you alongside the login information. We've seen that some people had issues with the password. It was saying that it was not typed correctly. If you're hitting that a lot of times and you're sure you're typing it correctly, just ping us and we can give you a different password. That's no problem. So once you get in, you'll see that you can select from a drop-down list the models that you want, and the AMD AI Training Assistant is there. So your drop-down list will be smaller than this one. You'll only have the models with the capital letter, because this is a screenshot that I took from the admin panel, from which I can pull models from Olama and are the ones with the lowercase letter. The ones with the capital letter are models that I created based off of the ones with the lowercase letter. They're just exactly the same, but they're made public so that users can see them. The admin can pull models from Olama and make them visible, but we'll talk about the admin tomorrow when we talk about how to actually create this. Okay, so the AMD AI Assistant is based on Gemma 3. And I actually would like to hear people's opinion on this, but at first we thought we were gonna base it on Llama 3.3, but then it was brought to my attention by Alessandro in our team that Gemma actually might be better because, well, for several reasons. One of this is here. So you can actually supply an image to the web UI, and Gemma 3 will be able to read that. So here I just asked, what is this, to Gemma 3, and Llama 3.3, and Llama 3.3 couldn't interpret this, whereas Gemma 3 correctly said that this is a dog. Just kidding. And I wanted to say that as you can see from this screenshot here, you can select multiple models. So here you see you can basically click on the plus and select multiple models and ask the same question to multiple models so that you can compare that side by side. And here that's what I did to show you that Gemma could actually work, Gemma 3, with this picture. So we can actually take it further. And what I did was I took this screenshot here from one of the Rockham blogs about the compute and memory partition for an MI300X. And I basically just asked the same question, what is this? Supplying this image to Gemma 3, so the base model, and the AI training assistant that's based on Gemma 3, but has been enhanced with all that additional context. And this is to show you that the assistant, because of that additional context, can perform better on AMD related questions than the base model. So see here, the base model wasn't, I mean, a lot far off. I mean, that was already a good answer, but the assistant correctly, mentioned the CDNA architecture that's specific to AMD, and in particular of the Instinct GPUs such as 300X. So something else that's very cool about this open web UI is that you can select a model and ask the model to base the answer specifically on one or more of the knowledge bases that we have supplied by using the pound key. So if you type pound on the prompt, you'll see that this drop down or drop up, in this case, I guess, menu will show up. And you see that the lines that have those cylinders are the knowledge bases that we have created. So those ones have multiple files in them. So if you have a question that you think is specific to HIP or Rockham documentation or OpenMP, you can select specifically that knowledge without necessarily using the AMD AI Assistant model. You could use Gemma 3 or Llama 3, 2, Llama 3.3, and then have that query go specifically look into that knowledge. Or you see, if you go down, you see that there's actually the single files that have been used for those knowledge bases that you could select. I advise against that, since those names are not going to be particularly self-explanatory. So, well, in this case, these are, because there's PyTorch check GPU access and JAX check GPU access, but there's going to be a bunch of readme.md that don't really tell you a lot. So I suggest you select a specific knowledge if you want to test this rather than the single files. So see here, we have uploaded a knowledge base with all the slides for all the 4 days that we have as of Sunday night around probably 2 a.m. Texas time. But as we finalize the slides during this event, we may fix typos, for instance, or add stuff. We'll make sure to update those in the knowledge base. So what I did here, I selected the knowledge base with the slides, and I asked what are 2 easy steps to start profiling PyTorch workloads, and then I asked both Llama 3.2 and Gemma 3, and you see, you get slightly different answers. So yeah, so that's something cool that you can do, and I recommend you try it. It's also very interesting to see that the knowledge base that we provided actually does help, because here I asked a tricky question to the base model and the AI assistant about what value you should expect from torch.cuda.is available if you are running PyTorch on AMD GPUs. So we have said already that unfortunately, when you are trying to query the GPUs with Torch, you still have to use CUDA as syntax, just as syntax. So some people that are not familiar with AMD software and or hardware might think, well, PyTorch doesn't run on AMD GPUs because CUDA is not AMD. And that's unfortunately what the base model is thinking, in quotes, right now, because it says, well, it's false because that checks for NVIDIA compatibility, and since AMD GPUs do not use CUDA, then it's false. Well, yeah, I mean, it makes sense, but it's unfortunately not correct. In fact, if you are running on AMD GPUs, that will be true. And you see, I talked about the scripts in the test suite to check that you can see the GPU and that ROCm is supported. And in fact, that's precisely one of the things that we check to make sure that PyTorch can see the GPU. So this slide here, if the others didn't convince you, hopefully justifies why we're doing this and why we're making this available to you during this event. Yeah, and also I asked the training assistant about how I can install AI software, and in this case specifically PyTorch, to run on AMD GPUs. And the answer, I would say, I like it a lot because you can tell that it's based off of the knowledge that we provided. Because, well, first of all, rightfully it says, yeah, the key is ROCm, you need to install ROCm. And then number 2 here, I like specifically because it says load ROCm modules, which is exactly what I would want it to tell me. And it even talks about our script to install PyTorch from source from our HPC training doc repo. And then finally, the icing on the cake is check GPU visibility, which is exactly what I think you should do. So this response made me quite happy last night. Yeah, and finally, what I was telling you about, you can, so the answer will show you the sources, and you can click on the source and it will tell you what the relevance to your specific question is in percentage. And then if you click on it, it'll show you the source, so you can see for yourself what that information was based on. So yeah, finally, this is, you had a disclaimer at the beginning, and now you have one at the end. So this is just to let you know that in case you are using the LLM to write code for you, you should keep in mind that it's probably the best practice to use the LLM just as an assistant, not, to have it blindly write code for you, because there's always the question of copyright and ownership. And so if there's no human that created it, then it cannot be copyrighted, unless you modify it substantially, and then in that case you can. And you also be careful, because with AI you might get code that's not copyrightable, but you can still infringe copyrights. So you have to always kind of take what you get with a grain of salt, and be critic of the answers that you get, and don't take the LLM's answer as if they're ready for you, ready to be deployed and to be completely trusted. So yeah, this is it for this presentation. Thank you for listening, and hopefully you're already having some fun with this tool that we provided for you. Okay, well, yeah, I actually ended the presentation a little earlier, so that will give you quite a bit of time to explore what we have talked about. I would like to ask folks how it's going with the exercises that Bob has shared, and if there's any blocker that people are hitting, or you need any specific guidance. You don't have to speak up if you don't want to. You can just ping us on the Discord channel. I'm reading the chat right now. Fabrice, if you want to, do you wanna give me more detail about what you mean by the multi-model version for Llama 3? So is that something I can pull specifically from Llama, or do I need to set like environment variables for that? Maybe I'll ask you on Discord. Okay, let me check if somebody needs help with the web UI. Okay, yeah, thanks, Fabrice. Yeah, I don't know if I can pull that from Llama. See.
Do you want to share your Discord screen so they can see the question
Oh yeah, this is in the chat.
in the chat?
Yeah, Fabrice was talking about multi-model Llama 3, because I showed that Gemma 3 was reading the images and Llama 3 wasn't. So I'm wondering, is it something that I need to enable Llama for that specific model? Or is it the model that has another name that I had to pull? Don't know. Okay, thank you. So Llama 3.2 Vision. Okay. And I'm curious to ask folks, when we sometimes do our HPC events, there's people that have their own code, say for CFD, for instance, that they try and compile on the system and run it with our software to see if it works. And because sometimes we have newer versions, they want to check the new version. How about for this event, are people running anything specifically? What codes are you running right now? Are you mostly focusing on examples from PyTorch repos or TensorFlow, or is there any code that people normally work with that are testing right now? And I should say, don't take the benchmarking numbers too seriously, since this is a shared resource. So most likely those are not gonna be credible.
Yeah, I would also like to mention that these are pre-production parts that we have salvaged for this event. And there may be some curiosities on some of the nodes. I heard this morning that SH536 is set in TPX mode with NUMA 4 region, so it may behave a little strangely. And if you see something like that, let us know and we'll try to fix it.
And is there any model that people like me to pull from Ollama and make available on the web UI? You can dump it in the chat or on Discord. Please, nothing too gigantic in terms of parameters. Yes, and please let me know if you need me to change your password for the web UI.
So we are currently running on MI300As and MI300Xs for these exercises. You can also run a lot of these on workstation GPUs. If you want to do this knowledge assistant that we described tomorrow on how to set it up, you can do it on a workstation GPU. Most of the PyTorch and other packages will also run on workstation GPUs. If it's not directly supported, you can sometimes fake it out by telling it it's a different model than what it actually is. And we have a question in the chat in the QA section about running this kind of a model on a workstation GPU. And the comment is that the documentation is a bit sparse. That's a kind way of saying there is documentation quite often, but it's hard to find. So that's one of the reasons we've set up this knowledge assistant to help find deep in the ROCm docs or somewhere else some information that may help you. And Giacomo, do you have the web page on the supported GPUs? We've got a question on that.
Yes, it's on the other presentation. Let me find it.
We should ask the knowledge assistant.
Right, sorry, I had a mosquito flying around. Yeah, actually, let me try that because that's on the knowledge. Let me actually do that live since we've got time. Okay, so I'm gonna, oh, sorry, select the slides. Oh, no, that's not this one. Okay, let's see. Yes, so it's taking the presentation as source, so we can open it up, and there it is.
Wow.
Pretty cool.
In a lot of ways, it's just sort of a enhanced search mechanism.
Yes. Yeah, and they say that 300A is supported, but there's actually an open issue. We'll talk about it tomorrow, and it's actually not supported. That's the reason why we had that GPU 60 node just for Ollama, because all the others on AEC6 are 300A, and there only the CPU works, so it would have been too slow to be fun.
Okay, this is for Ollama, which is one of the questions, but we also have a question about the whole software suite, what is the supported list of GPUs? And that is in ROCm docs, but it can be hard to find.
Well, let's try it because I uploaded documentation as knowledge. Well, actually, I'm using the pound on the assistant, so that's probably overkill, but let's try that. So ROCm 641 documentation. What AMD GPUs are supported for ROCm 641? 64?
Let's try one, yeah. So the other advantage of having this knowledge assistant is you can download the ROCm docs for the version you are running. and that can help get a better answer. And basically, if it says it's a supported GPU workstation, it will support nearly the entire software suite except for managed memory is not enabled on the workstation GPUs.
The document don't explicitly list all supported GPUs for ROCm 6.4. However, they imply support through testing and validation. Let's try and do 6.4.1 because that's the documentation I gave it. Let's see if anything changes.
And as an
But
aside, this will run on your CPU, but it will be painfully slow.
I was really tempted, Bob, to upload a picture of us as avatar for the assistant to make it more realistic. Next time. Oh yeah, and by the way, I think I forgot to hold on, let me stop it because I forgot to give it the knowledge. I don't think it was necessary, but let's do it. Sorry. Okay. Yeah, because the documentation PDF is pretty long. So if this could help us fetch the relevant info, it'd be pretty nice.
Giacomo, while you are doing this, I want to share something with the audience here.
Oh yeah, do you wanna grab the screen, Jose?
Yes, just for 2 minutes, and I will give it back to you.
Please go ahead, please.
Okay, so the AI assistant that we saw, I can tell you that here we are working on, if I remember, I think it was installed on MI200X in the backend, but using the same instruction, you can install this on a workstation. I did it by myself using the instruction that are provided by Giacomo here. I was testing this on AMD Radeon RX 6900 XT, and it worked fine without any problem. The other thing is that is a question we got from, I think from Fabrice or from someone on Discord. He was asking if what can I say, GPU supported or something like that. It is a question someone in Discord here. Well, but anyway, if you go to this page, for example, you will see where the software stack where you can install this. You can even install on a laptop. Laptop, you have different. You have the workstation. You have laptop, and you also have data centers, things like that, where you can install all these software, AMD software stack to play with your AI applications. So it is fully supported in multiple hardware. So that is the answer I want to give to someone. It is a question, I think. Yes, it is from Francois.
Yeah.
So I hope France. Okay, perfect. Thank you. So yes. So that's it, Giacomo. That's what I want to share with the audience here.
Thank you, Jose. So let's see what the model said. Sorry. Oh, no, never mind. Sorry. Okay, based on the provided documents, while they don't explicitly list all supported GPUs, here's what can be inferred from the texts. MI300X and 300A, which, well, yeah, so it sent the link. Oh no, which is not working. That's disappointing. And these are the sources. What did it pull from here? Let's see, from the docs. It's probably gonna take a second before it can load the whole PDF. Probably many seconds. Come on, almost done. Yeah, the doc PDF is long, too long to load. Oh, well, it didn't point us to any line specifically. What else did it use? This presentation is our presentation on sysadmin. We do have a table on supported architectures. I wonder if that's one what it used. Yeah, this is pretty cool. Yeah, so see, from our presentation on sysadmin, we have this slide here that talks about the architecture supported by ROCm, and it pulled exactly this slide, which is what we needed. So yeah, so it's, you see, having the sources can help, because even though the answer itself was not very very good, I would say, you can take a look at the sources and actually get better answers by looking at the content that it pulled. I wonder what it got from here. Just curious. Oh, this is not super relevant. It's just about rock prof for the profilers. Let me just look at another one real quick. By the way, yeah, if anyone is wondering, this sysadmin talk is our presentation on installing the software, basically. So it has a lot of information on installation and where to find the necessary scripts. Yeah. So Bob, is there anything else that you wanted me to ask?
Yeah, let me look at the general questions. Okay. There was a question about how to tell if you are using Slingshot with PyTorch. Let's see if we can pull that one up. I don't know. That's a good one for Samuel on day
Let's
4.
try it. Yeah, let's try it. Oh, sorry. That's not correct.
Samuel and Teo will
Where
be
is it?
doing a presentation on day 4, and you can ask him that question. But let's see if the knowledge assistant is helpful for that. I think this kind of enhanced documentation is going to be needed for most HPC workloads, just because documentation is always lagging. Things just change too fast.
Yeah, and we talked a lot about prompt engineering, but the prompts I'm giving right now are not very engineered, but that's just for the sake of time. Oh, and by the way, as you can see here on the left, you have all the chat history, including the one about identifying the cat. That's giving away sensitive information.
So what happens when you do your prompt and you say, I am an expert on GPUs? It will go through the RAG documents and score them for which ones are most relevant for that expertise. And that's why you provide that. And then you provide input on what type of output you want, whether it's a full program, a list, suggestions, and that'll help it put the output in the form that you want.
I know why it's taking so long. Let me see if maybe
Somebody's on the
it
system.
didn't hang. Yeah, I'm wondering if it's hanging. Oh no, it shouldn't be hanging. How many users do we have on? It should tell me. Yeah, I'm wondering if there's heavy usage right now. Usually here it should tell me how many people are logged in. Let me see if it's not working anymore. Is it working for anybody else? Looks like it's on. Probably just slow. Is it working for you, Bob?
I'm not on right now.
Ah, okay. I'm assuming it's just being a little slow. Maybe there's a lot of people using it. Because it.
Let me see. No, there doesn't seem to be. Well, there's a fair load on it.
In the meantime, let's see if I can answer questions on Discord.
You may have been the first person to be successful at stumping an LLM. They're usually way too eager to respond with an answer, even if they don't know the answer.
Okay, so it's done. Let's see what it says.
It's a little too verbose.
Yeah, that's probably not a good sign.
It's
Okay, so description of Slingshot, okay. Description of ROCm, okay. Why he should use it.
yeah, I think this one struck out.
Let's just see what sources it used. Do we have anything in our content about Slingshot? I think maybe Sam's presentation.
Yeah, we got a couple
Talk
places.
about.
Slingshot is mentioned as you should be configuring to
Here.
use it, but I do not think we have a spot where we say how to verify it.
Which is very important. Wow, so it found that slingshot comes up in this slide, this benchmark from Lumi. Cool stuff, but it doesn't necessarily say that. Okay, what else do we have?
I think there's actually a slide, it may have been in the morning presentation about nickel and how to set nickel to use slingshot.
I don't see the morning presentation in the list.
Let me pull it up.
Yeah, maybe did Jose have anything on it?
Let me pull it up. Okay. So
Go
this
ahead.
may be a little deep for it to figure out. And this is one of the, so here we're showing that nickel, or nickel, which are the same thing, should be set to slingshot. And it shows here that there are more than one interface and you want the slingshot one. And so you set it there to get the slingshot. So the fix here is at the bottom to set it to HSA, HSN 0, HSN 1, HSN 2, and then it'll bind them. So that's what you have to do. How do you verify it? That can be tricky. I would do a performance, run a bandwidth and see if the bandwidth is what you're expecting.
Which deck is this, Bob? Sorry.
This is actually from,
Just so I make sure I did put it in the knowledge.
I think you have it. This is AI optimization and profiling overview from day 4, but I think it was actually following this CXI plugin this morning. And you notice if you're on Lumi, use the Lumi containers to get the environment. So you're not going to get it with downloading a wheel. And one of the problems with the HPE system is that this is proprietary software. So it's only available on that site. Okay. So yeah, this is one of the problems, is that the documentation has to include a link that refers to the question being asked. And so it may not pull it up if it doesn't mention those specific words. Okay, I think we're going to wrap up for the day. We're a little bit early, but you can continue to try the exercises and the Open Web UI. We're going to work on trying to get the SSH access. Any issues still remaining with that, we'll try to get those fixed up. I'm seeing several issues that are common. Make sure you're on the system, the laptop or workstation that has the keys that you're using, that you sent us. Make sure the permissions on the files are restricted to only you. If you're getting a request for passphrase, that means you set a passphrase for your key, and that's on your end. So if you don't have that passphrase still, you'll have to create a new SSH key. Most of our setup is very automated to load up the keys. So check your end first, see if there's any issues there. Add -VV to the SSH command and see if it gives you some clues what's going on. And if you continue to have problems, then come to us and see if we can figure out what it is. It is difficult to figure out what's going on with SSH.
Yeah. And I'll try to pull the other models, GPT, OSS, and Cogito, that have been mentioned in the chat. I might do it tonight or tomorrow because I'm worried that I'm gonna have to stop the current Olama serve process. And I don't want to disrupt people's workflows right now.
Okay, so we'll wrap up. Tomorrow we're going to be talking mostly about Python supported programming tools and how to get them to run on GPUs. And then following day 3 will be AI for science presentations. And then the last day will be optimization and profiling. So we'll be getting into more detail there. And now I'm going to turn it over to Seema to close out.
Thank you very much for the great session that you had. So Mari, also you are there, no? I feel
Of
so.
course, I'm here. Yeah.
Okay. So we thank all the participants, also our AMD experts. Thank you very much for your effort and for your time. So we are again starting tomorrow at the same time, and we are looking to all to connect and start running your code again. So thank you very much. Have a great day.
Thank you. Bye.
Bye bye. Thank you.
Thanks, everyone. See you tomorrow. Have fun in the meantime. Bye.
A little sleep in the meantime.
A little not, yes.
Yeah, you. Thank you very much. Thank you very much.
Thank you, everyone. Bye.